So you are asked to find the equation of a line that is lying on a Cartesian plane, and the right equation of a line must have the gradient and the c value. They are constants, okay, and the x and the y, these coordinates, they varies, but otherwise m and c, they're constants. So the only way now to find the actual equation of a line is to substitute what needs to be substituted and then state the obvious. Okay, so for example, from the line that we already have a line, thank God. So like we said the general equation of a line is y is equals to mx plus c. Okay, so y and x, there are two methods to find the equation of a line. Okay, either number one, you can use it by finding the gradient first, like finding m first, right? Or method two, you can use the substitution of coordinates of x and y. Okay, so these are the two methods that you can use to find the equation of a line. Okay, where you fill in the constants, the m and c. Okay, so for example, now we said if you look at our line, the obvious coordinates that we have, if we were to use the method of substituting coordinates, the coordinate that we can use, the obvious actually, initially we already know like our c. So we said since we said c is a point where the line cuts through the y-axis, so y will become mx plus 3. Okay, so the next thing will be to find the gradient, right? So the gradient is either by finding the m, can be found, or by substituting the x and the y so that you find m. It can be a long route. Okay, using method one. Okay, let's use the first method, finding the gradient. So gradient m is equals to change in y over change in x, or y2 minus y1 over x2 minus x1. Okay, that's gradient. But if you look at our equation here, the simplest way to find gradient is, we said gradient is dy over dx, right? So change in y, come here. Okay, you draw your imaginary triangle. So the triangle, the simplest triangle that is simple for us, the one that we know the length of the sides, like for example this one with our 0 here, so we definitely know that there is 3 here. Okay, and 0 here to there is 4. Okay, and the next thing now, you have to be specific with knowing that when you're calculating gradient here, listen carefully. Okay, so if you move downwards, right, here we're moving downwards like this to this 0, our change in y will be a negative. It will be negative 3 because we moved downward. Okay, then we move forward along the x-axis. This is positive 4. So our gradient now becomes dy is minus 3 over 4. Okay. Therefore, our equation of a line now will become y is equals to minus 3 over 4 x plus 3. That's our gradient using the method of calculating gradient. Okay. Using the method of substituting our coordinates, right? We can use that one. Let's see if we find the same gradient. Sorry about that. Okay. Okay, let's just make a little space here. Okay. So the first thing that we'll do now is we're going to identify a point. So it will be easy for us. We can just pick a simple point. The points that we know here, we have a 4, 0. Okay. And here it's a 0, 3. Okay. Right. So 4, 0. By substitution, okay, y is equals to mx, wow, plus 3. Okay, so y is 4. I'm sorry, let's use a coordinate that doesn't eliminate m. So we are going to use alright, yeah, I think I'm fine. So our y, substituting our y here, say this is xy, right? So substituting our y here is 0 is equals to m, and our x is 4 plus 3, okay, which is equals to 4m plus 3 is equals to 0. We group like terms, we end up having, right, minus 3 is equals to 4m. Okay, we divide by 4, so m is equals to minus 3 over 4. So we have the same gradient as the one that we got initially, which confirms. So therefore, our line now becomes y is equals to minus 3 over 4x plus 3, which confirms, like, it's just the same with the previous that you got. So that's basically how you find the equation of a line. You simply have to find the constants, because the coordinates, the y and the x, they varies. So the equation of a line, you have to find the gradient and the value of c. Okay, I hope you got 1 or 2 from this video, and yeah, do well to subscribe, to like, to share, and comment, and yeah, thank you.